Hello viewers, welcome back to my channel. I hope you are enjoying all the videos that I'm uploading for the coding questions. So today I'm back with a problem called unique paths. So this is the first dynamic programming video that I'm doing for my channel. So hopefully I'll do more in sequence from now on. So this problem is about a robot which is located on the top of the grid, and we will have to find the number of unique paths from start of the grid to the end of the grid typically. So let's go look at the problem description. A robot is located at the top left corner of the m by n grid, marked start in the diagram below. So basically this is where the start is, and the robot can only move in either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid, marked finish in the diagram below. How many possible unique paths are there, right? So this is a start and this finish. Basically the top left corner is the start and bottom right corner is the finish, right? So that is the start and finish, and we need to find out the number of unique paths possible from start to finish. So that's the problem. So now we are going to solve this by using a technique called dynamic programming. So first let's try to understand the naive cases, like if there is only one row, one column, right? How we are going to solve. If there are two rows, two columns, how we are going to solve. So typically this is an m by n grid, but once we solve for the naive cases, the same process should be applicable, or we could apply it for all the m by n cells, right? So let's try to understand primitive cases, right? So if it is just 1 by 1 grid, that means there is only one cell, so that is a start cell, which is also the end cell. In that case, obviously there is only just one path, right? So you don't have to do anything for that. But let's say 2 by 2 grid, right? So that is typically you have two rows, two columns, and I mark them as all zeros, but yeah, it doesn't matter what the numbers are there in here. So that is just a representation of the grid here, right? So what we are going to do is, in order to calculate the unique path, so as we said, dynamic programming is a technique that we are going to use. So let's create an array of m by n, so which is equal to the array that is given, right, to store the number of paths. So that means what we are saying is at ij, at a given index ij, it will denote the number of paths that are possible from 0 to 0, that is the top left corner, to I and jth cell, right? So I and jth cell. So let's go with the 2 by 2 array, that is initially that is this. So 0 0, that is the first cell, will be 1, because that's what we learned, right? The first cell, it should be 1 because there is only one way to reach the start cell. So that is the initialization that's what we call. So remember that we can move only two directions, right or down, right? Either right or down, that's it. So from 0 0 to 0 1, right? So this is typically a 0 0 and this is typically 0 1, right? So on the same row, so you will be able to go from 0 0 to 0 1 in, like, there is only one path existing, because you can only move right or down. So from here to here you will move right, so that is just one path. Similarly, from here to here also you can just move down, that is also one path. So that's what I mentioned here. From 0 0 to 0 1 there is only one path, and also from 0 0 to 1 0 there is exactly one path. So what we are going to do is, so we determined at 0 0 we have to put a 1, so this 0 we are going to change it to 1, so we changed it. And 1 0 1 0 0 to 0 1 also there is one path, so we changed it to 1, and 0 0 to 1 0 we changed it to 1, right? So this is how the array is going to look, right? So this array will have the number of paths from 0 0 to whatever the ij. So the one which we haven't filled is this one. So 1 1 we haven't filled yet. So with this we filled 0 0, with this we filled 0 1, with this we filled 1 0. We haven't filled the 1 1 yet, right? So now so these are all like initializations that you can say, right? So now comes the dynamic programming technique, right? So what we are saying is from 0 0 to 1 1 we have two possible paths, right? So you could go from 0 0 to 1 0 and then 1 1. So that means, so you come here and you come here, that is down, and then you take a right. So that is one path. Or 1 0 0, this is here, right? From here to you go right and come down, right? So that is second path. So basically what we are going to essentially do is whatever the number it is here and whatever the number it is here, so the sum will be equal to the number this here, right? So that is what we need to put the sum there, wherever the 0 is there right now, right? That is at 1 1 cell. So the cell which is 1 1 indexed, right? So there it is nothing but what we are going to do is add the contents of the cell 1 0 and the cell 1 0 1 and put the answer in 1 1. So that is what we are going to see, right? So basically this is the process of the dynamic programming we are going to continue until m rows and n columns. Finally, whatever the value that you have at m minus 1 and n minus 1th cell, typically that is the right bottom corner, right? So right bottom corner. So that is the answer that we are going to return, because all we need is the number of paths as output, right? So we are going to do the exactly this. There is since we just took only 2 by 2 array, so these steps are little simpler, but we need to generalize these 3 steps. Typically the first step is same for any number of m and n, but for these two we need to generalize. So we are going to look at the generalization code just in a bit. So now let's go look at the code, right? So as we said, I am going to declare an array of m by n, right? So this is the initialization of m by n array. So by default they are all initialized with 0 typically, okay? So now what we are going to do is, so this is the magic, right? So this for loop is the magic. So since it is a grid, we are going to have a row and column wise traversal, right? So if I is equal to 0 and j is equal to 0, that means that is the starting cell. If so, what we said is the array should be the cell should be equal to 1. So that's what we said. And then if I is not equal to 0 but j is equal to 0. So typically what that means is I is not equal to 0 but j is equal to 0. That means the first cell in each row, right? So row is not equal to 0 but column is equal to 0. So that is typically the first cell in each row. So typically the first cell in each row, what we are saying is mark it as 1. So that is what we did, right? So this is this cell it is talking, since we are generalizing, all the first cells will be marked as 1, right? So that is what it is. Or this one is first row. Basically I is equal to 0, j is not equal to 0. So this will be first row. So the first column and first row, what this if will do is the first column and first row will be marked as 1, because typically there is only one path to reach any cell in the first row. There is only one path, and if you want to reach any cell in the first column, there is also one path, right? So the other cells we are going to employ this logic of dynamic programming. Basically what we are doing is I minus 1 j and I j minus 1. So we are trying to add the contents of I minus 1 j and I j minus 1 cell and put that into a array of ij. So that's what we saw in the example, right? So what we said is right now let's say I j are 1 and 1, right? I minus 1 j, I minus 1, I is 1, j is 1, right? I minus 1 is 1 minus 1 is 0, j is 0 1. ij minus 1. I is 1, j minus 1 is 1 minus 1 is 0. So the contents of 0, 1 and 1, 0 we add and put into 1, 1 cell, right? So that's what we said. So that is what the output going into array of ijth cell, right? So this will be continued for all the rows and columns, right? So and typically after that you are going to return the m minus 1 and n minus 1th cell content. So that is the right bottom corner, right? Bottom right corner. So whatever the number that appears there, you are going to return that number. So that will give the unique paths for m by n grid. So this is a way to solve with a dynamic programming. So there are multiple ways to solve a given problem, but this is a cool application of the dynamic programming, right? So let's go look at the time complexity for this, right? So this for loop is going to take order of m, and this is going to take order of mn, right? Order of m into n, right? So totally order of m plus order of m into n, that is the time complexity. So since we only take the bigger ones when we deal with the big O notation, so the total time complexity for this will be order of m by n, order of m into n, you can say. And let's look at the space complexity, right? The space complexity that we are using is, we are declaring this array with m by n, right? So m by n, right? So the space complexity is also equal to order of mn. So in this particular case, the time complexity and space complexity both are same, which is equal to order of m by n. If you have any questions on this problem, please leave your questions in the comment section. I will answer. If you like the video, please subscribe to my channel and share among your friends. If you are looking for one-on-one coaching session or mock interviews or interview guidance, please reach out to me, or you can leave your email in the comment section. I will get back to you. Thank you for watching. I will be back with another video very soon. Thank you.